Let's take a look at this example. This time we're supposed to design the dual input balance output differential amplifier using the diode constant current bias circuit. Okay, so this is my differential amplifier and this is my diode constant current bias circuit. Okay, as you probably noticed, we have not given R1 and R2 and we have not given R3 and R4. We have to find the values of resistors okay, for this circuit. So the very first thing which we're supposed to do is supposed to check what is given. Okay, we have given collector current IC. I mean this is IC1. Okay, IC1 is equal to 2 milliamps. Okay, 2 milliamps. You have to realize that IC1 is equal IC2 for the differential amplifier, and this is equal in our case 2 milliamps. Also, you're supposed to realize that the current IC1 is approximately equal to IE1, and this is also equal to milliamps. Also, IC2 is approximately equal to IE2, and this is equal to milliamps. Okay, so I know the current which will go through the emitter of transistor Q1 and Q2. So what we're supposed to do next? We know the currents and we have given gain. Okay, if I have given gain, I'm supposed to find small re. Why? Because I'm going to use the formula for the gain to find the value of resistance which is connected to the collector of transistor Q1 and Q2. So Re is equal 26 millivolts over IE1, and remember it could be IE1 or IE2, doesn't matter which one, because the values of both of them are the same. So this is equal 26 millivolts divided by IE1, 2 milliamps, is equal 13 ohms. Okay, so this is the value of small re. Next, I'm supposed to write the formula for the differential gain. So AD is equal RC over small re. If you are going to solve this formula for RC, you will find out that RC is equal the differential gain times small re, where the differential gain is given, this is my voltage gain, 70. I have 70 times 13 ohms. So RC is equal 70 times 13 equals 910. So this is 910 ohms, and this is equal to my R1, and this is also equal to R2. So this is 910 ohms, and this is also 910 ohms. Okay, next we can find the current which goes through the collector of transistor Q3. So I can say that IC3 is equal IE1 plus IE2, and this is equal 2 milliamps plus 2 milliamps is equal 4 milliamps. Okay, so this is my IC3. You're supposed to also remember that the base current is having a very small value comparing with IC and IE. That's why I'm going to assume that IC3 is approximately equal to IE3, which is also equal to IR3. This is the same thing, and this is equal also 4 milliamps. Next, we're supposed to find the voltage across resistor R3. In order to find this voltage, I'm supposed to find the voltage at the base first. Voltage at the base first is the sum of the voltages. I mean, VD1 plus VD2 plus VEE. Okay, so I'm going to write that VB3, and this is going to be also equal to the voltage across resistor R4. So this is VR4 is equal VD1 plus VD2 plus VEE. Okay, and this is equal my voltage D1 is given, okay, this time is not 0.7, is 0.62 volts. So I have 0.62 volts plus 0.62 volts plus negative 15 volts. Okay, so my VB3 is equal 0.62 plus 0.62 plus 15 negative, I'm doing everything step by step, is equal negative 13.76 volts. Okay, so this is the voltage at the base of transistor Q3 and voltage across resistor R4. Next, I have to find VE3. VE3 is equal VB3 minus VBE. Okay, voltage at the base minus VBE will give me VE, where VB3 we found is equal negative 13.76 volts minus 0.67 volts. Okay, 0.67 volts is given. Okay, VBE is equal 0.67 volts. So this is equal negative 14.43 volts. Okay, so we found the voltage at the emitter of the transistor Q3. Next, we're supposed to find the voltage at the resistor R3. So VR3 is equal VE3 minus VEE. Okay, so voltage at this point minus voltage at this point will give me voltage across resistor R3. So this is equal VE3 we found is equal negative 14.43 volts minus negative 15 volts. Okay, this is equal 0.57 volts. Okay, so this is the voltage across resistor R3. Next, we're supposed to find the resistance. Resistance R3 is equal VR3 over IR3. VR3 is equal 0.57 volts divided by IR3. Okay, but please notice that this is the current IE3. Okay, and IE3 we found is equal 4 milliamps. That's why I'm going to write over here 4 milliamps. Keep in mind that anytime I say IE3 or IR3, this is the same current. Okay, because it goes in the same branch. So this is equal 0.57 divided by 4 exponent 3 negative. This is equal 1 142.5 ohms. Okay, so this is the resistance of resistor R3. Next, you're supposed to remember the property, okay, for the constant current bias, okay, with the diodes, that IR4 in this case is going to be equal approximately IR3, and this is equal IR3 we found is equal 4 milliamps. Okay, so if you want to find R4, again you're supposed to use Ohm's law and simply write VR4 over IR4, where VR4 we said is the voltage at the base of transistor Q3. Okay, voltage at the base of transistor Q3 is equal negative 13.76 volts. Okay, because I'm looking for the resistance, I'm going to use the absolute value. So this is 13.76 volts divided by IR4, and we said this is equal 4 milliamps, and this is equal 13.76 divided by 4 exponent 3 negative equals 3.44 kilohms. This is 3.44 kilohms. Okay, so we found resistors R1, R2, R3 and R4. So let me just write them down. We found that R3 is equal 142.5 ohms and R4 is equal 3.44 kilohms. 3.44 kilo. Okay, so now we can say that the problem is solved.